Hey guys, we're here with Mrs. G's class, and they are going to make a video for us so that we know how to measure our frogs carefully. So, oops, I'm going to move this back a little bit. Alright, so let's just say that here is our frog jumping contest. So, we need to talk about data. How do we get the data? How do we record the data? So, you know that our floor is covered with tile, nice straight lines, and we use those as the starting lines. So most kids are going to say, you know what, I'm going to put the nose of my frog on the starting line, because if I start with the nose here, I'm going to want to measure to the farthest point, which probably is going to be the nose. So you think nose to nose, that's a good way. But watch what happens. What if I take my frog and his first jump is like right here. Now you think, okay, you have this data sheet like this. You have boxes. You're going to record your data here. You're going to test your frog out a couple different methods and record it today. So think, all right, well let's take a look at how far did this frog go. So if I jump and it lands up right there, probably the first thing you're thinking is, all right, well, if he jumps from here to here, how far is that? So you can kind of eyeball it and say, well, that would be about 2 centimeters. So what you're going to do on your sheet is you're going to say, okay, experiment number 1 is right here. You're going to say first jump, oh, that was 2 centimeters. Now your partner is also going to record your jumping and you're going to record theirs so that we can double check each other. So they're going to say, okay, yep, 2 centimeters. They're going to do that on their sheet. You're going to do that for them on their sheet. Now, here's where the problem comes in. Some kids aren't good at collecting data, or they record it wrong. Now watch what happens. Let's just say that the next jump of my frog ends up right here. Now when he ends up here, what number should I record? 5. So your partner says, yep, okay. So my next jump is from here to there. And he says, yep, it ended up at 5. So he puts 5 over here. But you, being the smart scientist, says, wait a minute. If I was at 2 and I jumped to 5, how far did he go? Well, he went 1, 2, 3 more centimeters. Oh, I'm going to put down that he went 3. Now, this is why we're double checking each other. Because right now, you might look at each other's paper and go, wait a minute, I think we have a problem. They don't match. Then you can talk about who's right. But for now, we'll just pretend that you didn't notice that yet. We'll keep going. And my next frog jump, let's just say that he ends up right here. Now, you might think, okay, how far is it from this jump to this jump? Now, the smart scientist again is thinking, well, if I started at 5 here, 6, 7, 8, 9, oh, that would be 1, 2, 3, 4 centimeters. So I'll put 4 centimeters. Now, your friend, the silly scientist, goes, oh wow, he jumped 9. Okay, I'll put 9 over here. Now, the last thing to figure out is, okay, I know how far each jump is. That's what we want to know. But then we want to know, okay, how far total did my frog go? So now we're thinking, all right, let's add these up. So for the smart scientist, what's 2 plus 3? 5 plus 4? 9. So he gets 9 centimeters. Now, does that match?
Yes.
So I think he knows, okay, the first jump, well, that had to be 2 centimeters. Does that agree with our data?
Yes.
Okay. The second jump, he says, is 1, 2, 3 more. Does that agree with our data?
Yes.
Yep. And then the third jump would be 1, 2, 3, 4 more. Does that agree with our data?
Yes.
Yep. So if he adds that up and says, okay, 2 plus 3 plus 4, yeah, that's 9. Okay, yep, 9, 9. If your total is where your frog is at, you did it right. Now watch the problem with your friend. Your friend might do this. What's 2 plus 5?
7.
Now what's 7 plus 9?
16.
Now your friend all of a sudden gets 16 centimeters. And now all of a sudden, look what happens. you look in here and say, is that 16? Now, if your total doesn't match where your frog ended up, uh-oh, we got problems. It either means that you added wrong, or it means that you recorded the data wrong. So, this guy, that's the road to good science. You got good data. This guy, he might not realize it till the end, but he's got bad data. He's crying because he's so sad his experiment didn't help him know the answer to his question. Are you understanding how to get the data and record it?
Yes.
All right, good.